Welcome to the course Excelling with Mathematical Modeling. Today we will be discussing a very important aspect of mathematical modeling, that is estimation of parameters. We have already seen how you can estimate the parameters in a function. So today we will be taking a differential equation which will represent a model, and the differential equation will contain some parameters. So we will see that how you can estimate those parameters using the data. So basically you will be having a set of datas, say the time and the variable x. So this will be some t1, t2 and so on. This will be some x1, x2 and so on. So by looking at the plot of this graph, so you will be plotting this two and you will be getting some values, some graph like this. So by looking at this graph, you have to decide that what kind of model can fit this particular data. So after you have decided what kind of model it is, say this is the model, then you have to use the method of least squares to estimate the parameter values. So let us directly go to the Excel sheet and see that how this is done. So as you can see that I have the data of E. coli strains. This is the growth data and the time is there and the growth is here. So I need to fit a suitable model and estimate those parameters with the help of this data. Now since it is a growth of this particular strain, so we will be using the growth model, and the growth model which we have studied are either logistic growth or Gompertz growth, which are a bit realistic than the exponential growth. So we will be taking the logistic one and also maybe the Gompertzian one, and we can compare which one is better. So if you try to fit the logistic growth, then your equation will be of the form dx dt is equal to r times x 1 minus x by k. So my parameters here is r and k. But before you state this equation, whether it is a logistic one or whether it is a Gompertzian one, that is k by x, where r is the intrinsic growth rate and k is the carrying capacity. So this is the logistic and this is the Gompertz. So as I was telling, before you write this equation, you just see that how this particular data looks like once they are plotted. So I highlight the time and the growth and let me plot a scattered diagram. So I go to insert, I choose the scattered diagram and I plot the data. So this is I write parameter estimation. So this is the first part that is done. Next is, I assume that this particular curve is modeled by this equation, the logistic growth, that is dx dt equal to rx into 1 minus x by k. So I have two parameters here, one is this r, another is this k. So I increase the font size and meddle them. And since we will be using the Euler's method, I have to take a h and the value of h I have to put say h equal to 1. The next thing is the predicted growth. So, this is the one which you already get from the data, and then you make the prediction with the help of this particular equation. So, the predicted growth, so I just write here predicted growth. Now, in the predicted growth, I need an initial condition which I coincide with this value. You could have put something else also, but since you already have the data, so I coincide the first value, that at 0.5 the predicted growth also coincides with the growth actual data. And then I have to attribute some values of R and K. You choose that arbitrarily, and then I calculate the rest of the values using the formula. So, the formula is we use Euler's method, and the formula says that y1 is equal to y0 plus h f x 0. So, this will be equal to, first is the initial value y0 or x0. In this case, since I am following this equation, let me take it as x0. So, x0 plus h, which is 1, and it is a constant. So, I make it a constant multiplied by r. So, this is r, again a constant, r times x0, which is this value, multiplied by 1 minus x0 divided by k. K is again a constant. That's it. So, quickly let me check it. So, this is y0 plus k 6, which is plus h multiplied by r, okay, and then I just drag it. Okay. So, now what you do is you got the time, you have the data, now you have predicted the growth by using this model. So, now let us see what is the difference between the data and the one which you have predicted. So, I will add the curve. So, I will say select data and I will add data. So, I name it as best fit, or let me write predicted. Now, x value, I choose the time, you highlight this and put the cursor down and press enter. So, x values have been here. The y values, I again press this, and the y values is the one which is the predicted one. You highlight all of them and enter. So, all the x and the y values have been, and you click OK. So, now if you see the graph, you now see that This is the data and the orangish one is the predicted value. Okay. Now quickly let me change this, change chart type. Okay, I want this one to be data. So put the legend, change the series 1 to data. So I go to design, I select data. So this we have already done, so I am not explaining much. So in series 1, I edit and I name it as data. Okay. Okay. So the blue one is the data and orange one is the predicted value. Let me change the data as points. So here is the data, I make it as points. Okay. So now I have this particular figure where these dots in blue are the data and this is the one which is predicted. So now how to estimate it using the method of least squares. So the first thing you do is you try to bring a good match by manipulating these values. Say I put it 2 and let us see how the behavior of the graphs. Okay, so it gives something like this. So 2 will not work. So let me put 0.1. Okay, again it goes down 0.5. Okay, goes up 0.3. Okay, somewhat like this 0.4. Okay, 0.7. So like this you bring the curve close to it, to the data. Yeah, so it is coming close. So you can play with this a bit so that a little good match is found. And then what you do is we use the method of least squares. So that will be the value which you got from the data minus the predicted value, which gives you the residuals. You square them, which will give the residual square. You sum them and then minimize the residual, which is just the error. So what I will do is this is equal to the data value and the predicted value. This will be 0 obviously because both are same, and if I drag it, I get some value. Now this is residuals, but let me directly calculate the residual square because we will be needing them actually. So I made them square. So this is the residual square. I just increase the font size. Residuals square. And then what you have to do is you have to take the sum of this square of the residuals. So this is equal to sum. You highlight this, press shift, go drag all the values this much, close the bracket and enter, and you get the sum. So, once you get the sum of the square of the residuals, now I have to minimize this value, and for that I will be using the solver. So, go to data, go to the solver, and this kind of window is opened. So, I have to minimize this sum of the square of the residuals. So, I click this and immediately the cell number is highlighted here. So, I have to minimize this value, and by adjusting the value of R and K. So, here I will choose this R and K, and immediately it has come here, and then keep all them as it is and click solve. Okay. So, as you can see that it has automatically adjusted the values using this solver, give a fit. So, this is the best fit that you can get for this particular data, and please note this is a real life data. So, it is not that you can expect that there will be an exact match of this curve with all the data. That is the best that you can get, and the parameter estimated values is R equal to 0.61 and K equal to 0.79. So, this is how it is done. Now, let us move to another example where we take two equations. So, let me copy the data. So, this is the time, and this is the say measured value, that is the one which you get from the data. So, this is measured P. Now, my variables here are some A and B, and I put it in the form say dA dt is equal to some minus K1 times A plus K2 times B square, and dB dt is equal to 2 K1A minus 2 K2 B square. So, I have this system of equation, system of differential equation ODEs, where A and B is my variable and K1, K2 are my parameters. So, I have to estimate the values of K1 and K2, and the parameters which are given, I mean the data which is given is only of B and not of A. So, the first thing is, let me see how these behave. So, I just go to the scatter diagram and this. So, this is how the data is behaving, and let us now fit this equation in the data and see what the values of A and B we are getting. So, they are the measured values now. Sorry, predicted values. So, this is the measured and this is predicted A predicted B. For that I need an initial value of K1 and K2. So, as usual I put them first to be 1 1 and then we can always adjust them. So, initial value, this is say 1 and this is equal to 0. So, I coincide this value with the data. This I chose arbitrarily. Now, first let us calculate the predicted value of A and B. So, this is equal to initially A0 plus H. So, I need a H, which again I take to be 1. Okay, so we attribute some initial value of this K1 and K2 and say I put 0.1, 0.3 and let us calculate the predicted value of A and B, and we use Euler's method. So, this is equal to the initial value of A, which is A0 plus H times multiplied by this part. So, minus K1, which is a constant, times A plus K2 which is constant times B square. Similarly, this is equal to B0 plus H multiplied by 2 times K1 multiplied by A minus 2 times K2 multiplied by B square. Close the bracket and calculate. So, highlight these two and drag them to all these values and I change the font to 20. So, let us now plot these values. So, I will add data to it. So, select add data, predicted A, the x values will start from 0 till 10 and the y values will start from, so this is the predicted A. And enter and OK, and add another value. This is predicted B, the x value will start from here all the times and the y value is the predicted B value. OK and OK. So, let us see how the figures look like. So, the chart look like this, and I need the legends. Go to design, select data, the series, edit and name it to data. And then the datas may be in dots, but this change to lines. So, change chart type. So, let the data be scatter, predicted A be a line and predicted B be also a line. Okay. And let us see if I change the color. Say I want a green. Yeah. So, this is now the data, the predicted A and the predicted B. So, the next step is you have to calculate the residuals. So, now you are dealing with the data of B and the predicted value of B. So, everything will be calculated for B. So, this is equal to the residual, which is the measured value or from the data minus the predicted value, and I have to calculate the square of the residuals. So, I square them and enter. So, this gives me the square values of the residuals. And the next thing is I have to calculate the sum of the square of the residuals, enter, and I get the sum. So, next is I have to minimize this sum of the square of the residuals. Go to the data, I use the solver. So, first I choose which I have to minimize, that is this cell. So, I click this and immediately it comes here. I have to minimize the value. So, I click it here and I have to adjust the variable cell, which is my K1 and K2. So, it came here and then keep them as it is and just use solve and OK. So, now you see that this is your data and it is a very good match. Your predicted A is as it is, whereas the predicted B is this green line, and your estimated value of K1 and K2 came to be 0.16 and 0.1. So, this is how you estimate parameter values using data in the case of differential equations. In my next lecture, we will again continue with estimation of parameter, but with difference equations. Till then, bye bye.